Welcome to this explainer. If you're focused on the future of education, or honestly, if you're just endlessly curious about how we teach the most complex subjects on Earth, you are absolutely in the right place. Today, we're unpacking a massive, modern evolution in science education. We're looking at how technology is literally breaking us out of those rigid, traditional classrooms and moving us into dynamic, scalable digital environments. So let's just dive right into it.
Now think about this for a second. Are hidden costs and limited time holding back hands-on science education? Well, for educators and administrators, this isn't just a rhetorical question. It's a very real, everyday headache. Traditional science classes are constantly battling against massive budgets for materials, super strict safety regulations, and just incredibly rigid scheduling constraints. And the unfortunate result? Too many students are left with only theoretical exposure to critical concepts instead of the actual hands-on practice they so desperately need.
So, here is our roadmap for today's explainer. First, we'll look at the science lab bottleneck. Second, we're defining virtual learning systems. Third, we'll dive into the benefits of going virtual. Fourth, we explore what happens when AI meets science. And finally, we'll look at a real-world example with the PraxiLabs case study.
All right, part one, the science lab bottleneck. Let's get into it. Think about your typical physical lab for a minute. They rely on really costly materials that just deplete over time, right? They require rigid schedules where students actually have to fight for shared equipment, and they inherently carry safety hazards that demand constant supervision and expensive protective gear. But on the flip side, the virtual alternative is highly cost-effective because, well, the materials literally never run out. Plus, it gives you 24/7 access without any scheduling conflicts, and it is completely risk-free. It's a huge shift from a restricted, passive observation model to one of scalable freedom and direct interaction.
Moving right along to part two, defining virtual learning systems.
So, what exactly is it? Well, a virtual learning system is essentially an online environment where students complete science experiments through incredibly realistic 3D simulations instead of physical equipment. And I want to be clear here, it's not just some cartoon. It authentically models real lab equipment, complex chemical reactions, and intricate biological processes with stunning visual accuracy. When a student jumps into this, they are looking at the exact same tools they'd encounter in a physical, real-world setting.
So what does this actually look like for the student on a day-to-day basis? Well, step one, they just access it from any device with an internet connection. Boom! No need to queue up for a physical lab slot. Step two, they follow step-by-step guidance that actually walks them through the procedure. And step three, they get to run repeatable experiments with instant results. You don't have to wait days for a scheduled lab session, and you absolutely don't need a technician to come in and reset the equipment after every single attempt.
Okay, let's move to part three, the benefits of going virtual.
Let's anchor this in a real hard number, 60%. Institutions that are adopting these virtual systems are seeing a verified 60% reduction in lab-related costs compared to physical setups. That is huge, because virtual equipment doesn't need ongoing replacement, it doesn't need calibration or maintenance across multiple semesters, it just frees up massive chunks of the budget for other vital academic priorities.
But hey, it doesn't just save money. It fundamentally transforms how students learn. We are seeing a massive 80% boost in learning retention among students using the platform compared to traditional lecture-only instruction. By bridging that gap between theoretical textbook lessons and actual hands-on practice, students are truly absorbing and retaining the complex mechanics of what they're doing. It is a real game changer.
Now, a huge driver behind that retention is a concept called safe failure. In a physical lab, making a mistake can mean ruined materials, blown budgets, or worse, a serious safety hazard. But virtually, mistakes carry zero material cost and absolutely zero safety risk. They can be reversed in a split second. And this low-stakes repetition really reduces student anxiety. It builds their confidence and encourages them to experiment and try different approaches without the fear of being punished for one little error. And all of this creates just incredible institutional benefits. We're talking unlimited experiment repetition for those concepts that are really hard to visualize. We've got safer exploration without needing to suit up in protective gear, standardized conditions, which, by the way, is absolutely crucial because it completely removes the annoying variability of inconsistent physical setups between different class sections, and finally, consistent access for remote learners, no matter what campus they're on. You can scale your science education without hiring more lab techs or pouring concrete for new physical labs.
All right, let's shift gears for part four, when AI meets science. Traditionally, students get these uniform, one-size-fits-all instructions regardless of their personal pace, and instructors have to spend countless, grueling hours on manual grading. But when you introduce AI, students receive personalized guidance that adapts to their specific pace and their previous answers. For the instructors, automated grading completely eliminates hours of repetitive scoring, which frees them up for actual, direct student support. Plus, AI pattern recognition can pinpoint struggling students and knowledge gaps super early, often before a formal test even happens.
To put a face to this AI magic, let me introduce you to Oxy. Oxy is an AI lab assistant built right into the virtual system that provides all this real-time, personalized guidance. It offers continuous, scalable support that actually learns and improves over time. So, as your enrollment grows, Oxy scales right alongside it, with zero need for the institution to hire extra teaching staff or force educators to extend their office hours.
Which brings us to Part 5, the PraxiLabs case study. Let's see this in action.
The scale of PraxiLabs is honestly mind-blowing. They have over 2.5 million active users spread across more than 160 countries. They offer over 210 science simulations spanning more than 20 branches. We're talking biology, chemistry, physics, the whole shebang. The platform is completely bilingual in English and Arabic. And absolutely crucial for the IT folks out there, it boasts seamless integration with learning management systems like Moodle, Canvas, and Blackboard in under 24 hours. No wonder it's picked up 11 global awards for its impact on science education.
And the demand for this kind of technology? It is accelerating fast. The broader simulation-based learning market in the education sector is actually projected to grow at a compound annual growth rate of 8.57% between 2026 and 2030. The entire industry is moving decidedly in this direction simply because, well, the results speak for themselves.
All of this leaves us with a final, pretty provocative question to take away from this explainer today. As student enrollments just keep growing year after year, why expand physical lab spaces when scalable digital alternatives offer better retention and lower costs? It fundamentally challenges institutions to rethink their dependency on bricks, mortar, and physical materials, and instead embrace the limitless, totally risk-free potential of the virtual lab. Thank you so much for joining me to explore this fascinating shift in education.